Bienvenidos, Ushamdi, and welcome, CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3, or the Cisco Networking Academy Scaling Networks V6 course, and this afternoon's video tutorial and solution set is going to be on Packet Tracer Activity 8.4.1.2, and this is the Skills Integration Challenge for single area Ospf configuration. So let's go ahead and dive into the activity and see what we have on tap. As you can see over here to the right, we've got all of the details that we're going to need to know. And in fact, I'm going to go ahead and pull it all the way down to there. Again, no completion percentage here. It's going to be it either works or it doesn't. And what I mean by that is we're either going to be successfully configuring things and we've got end-to-end connectivity between the PCs via IPv4 and IPv6, or we do not. So let's go ahead and dive into the requirements to configure use the following requirements to configure router A addressing for Ospf V2. So let's get router A up here and give ourselves a little more space with which to work. And this is a Cisco 2911. So here we are. We'll go from user exec to privilege exec. And let's say show IP interface brief. I believe, yes, we are going to be asked to configure everything here. So let's get into global config. Interface gigabit Ethernet 00. IP address is going to be 172.31.0.1, and this is a /23. So they're trying to get a little tricky with us here, a 254.0 subnet mask. All right, now let's get into, and we're going to say no shut. Definitely want to remember that. Let's get into interface serial 000. IP address here is going to be 172.31.4.1, and this is going to be a /30. And again, we want to give it our no shut. Now, it says it's down because the other side of the link is currently down. So that's okay. So we've got all of the IP addresses configured here. Let's get to the Ospf configuration. So router Ospf, and does it tell us? It doesn't look like it tells us. It looks like this is going to be sort of open-ended here. So we'll just say router Ospf 1. Now, right out of the gate, I'm going to passive interface gig 00. And let's set the router ID to 0.0.0. I'm sorry, they want 111. All right, so we'll use what they provide. Oh, process ID 1. I almost read right by that. So process ID 1, network address for each interface. So network is going to be 172.31. Oh, and I know why they're doing this. Why they did the /23 is going to become apparent here. So 172.31.0. What? .0, but what is the wildcard mask here? It's going to be 0.0.1.255, right? So that, oops, sorry, and we need area 0. So that would be the inverse of the dotted decimal notation net mask. And then I also need a network statement for 172.31.4.0, 0.0.0.3, area 0. And so we've got that taken care of, and we passived the interface, so we're good on router A with our IPv4. Now we're going to transition over to router B. And so here is router B, and it looks like router B's got a little more going on because it looks like we may have some IPv6 configuration that we are going to need to take care of here. So here we are on router B. We'll get to the CLI. We'll go from user exec with enable to privilege exec, and then configure terminal to get us into global config. And we are going to set the gig 00 link address, link local address. Okay, so first we're going to say IPv6 Unicast routing. We know we're going to need that. So let's knock out the Ospf V2 configuration first, but do show IP interface brief. Yeah, everything is not configured. Nothing's configured and everything is down. So let's do this. We'll do our gig 00 first, and I'm going to say IP address 172.31 .2.1, and this is a /30. Wait a minute, I'm in gig 00. Hold on here. Yeah, 172.31 2.1 /23 again. So 255, 255, 255, 250, oops, sorry, 254. .0. We're going to say no shut to bring that interface up. Now we also have IPv6 address FE80::, and they want us to use ::1 for our link local address on gig 00. So we're going to do that. And then we also have IPv6 address 2001:DB8:, what is that going to be? :1::1/64. All right, so we're good to go there. Now let's get into interface serial 000. Now this only goes to router 1, and router 1 only does IPv4. So we're going to say 172.31.4.2, and this is a /30. And we definitely want to say no shut. That should bring the interface up. I should be able to ping 172.31. And where is that at? 4.1. And there we go. And so that is up. So we're good there. And then interface serial 001. So we'll say no shut to bring that interface out of the administratively shut down state. And then let's get our IPv6 address. So it's IPv6 only going this direction. So IPv6 link local, I'm sorry, IPv6 address for the link local is going to be FE80::1. And then we need IPv6 2001:DB8:2::1/64. Now remember, on these transit segments between the routers, do I have to have, on these transit segments here between the routers, do I have to have global unicast addresses here? Or can I just do link locals? And the answer is you only need link local addresses because those are the addresses over which the adjacencies are going to be formed. So let's take one last look at router B here. I want to make sure I got that address right for serial 001. And that was 2001:DB8:2::1/64. And then I don't believe we said, or we did say no shut. All right, so now let's get into the Ospf configuration here, right? So we're going to say router Ospf wanted 1. And then let's set the router ID here. So router ID to 2.2.2.2. And going back, I keep going back and forth between the directions here. We're going to passive the gig 00 interface, right? Set that to be passive. We got that. So then our network statement for the LAN, 172.31.4.0, 0.0.0.3, and this is going to be in area 0. And as soon as we do this, we should see that we have an adjacency form between router 1 and router 2. We'll give it a second here, and let me make sure I got that address right. 172.31.4.0, and we did. And I did do show IP interface brief. Let's make sure the interface is up. All right, that interface shows up. Let's check router A here and make sure that I did not mistakenly. No, we're good there. So let's do this. Clear IP Ospf proc, and we'll say yes. And we're up, and let's ping 172.31.4.2. So show run, let's see what we've got in our Ospf config. And maybe I overlooked something here. Okay, we passive the gig interface, and that is a /30 between these two guys. Let's make sure I configure the right interface. Serial 000.172.31.4.1. And we did. Show IP Ospf neighbors. We should not see anything. We don't. So it's got to be something I did here on router B. So let's stretch that out a little bit. Do show run. Maybe I left an interface shut down. No, 172.31.4.2, so we're good there. And in my OSPF config, what did I forget? Network 172.31.4.0, area 0, so everything is good there, and the router ID is confirmed. So then the question is, why is it not liking that? All right, let's troubleshoot this. Do show IP protocols. 172.31.4.0.0.0.0.3. Did I? Let's make sure we got that statement right here. 170, there we go, 172.131. So let's get into global config, and we're going to say router OSPF 1, no network 172.131.4.0.0.0.0.3, area 0, and then network 172.31.4.0. And this should give us a much better result. There we go. All right, so back to router B for the Ipv6 configuration. So I think we already said Ipv6 Unicast routing. So Ipv6 router OSPF 1, and process ID is 1. And so that's actually something very important. You'll notice that the Ipv4 process ID and the Ipv6 process ID are the same, right? And so that is okay, right? So both of those IDs are the same. Process IDs are the same. All right, so we're going to go ahead and say passive interface gig 00. We're going to give it the old router ID here of 2.2.2.2, right? And then we need to enable under the gig 00 interface Ipv6 OSPF, where are we at here? OSPF 1 area 0. And then I'm also going to go under interface gig serial 001. I'm just double checking on my interfaces here. 001, and we're going to do the same thing. And that should be it for router B. We don't need the PCs yet. So let's go ahead and let me make sure, did we get the do show Ipv6 interface brief? All the information is there and we're just down. Okay, good. So let's pull up router C. Go from user exec to privilege exec into global config, and router C is Ipv6 only, right? So we're going to be doing OSPF V3 only. So Ipv6 unicast routing, and then we're going to come back with, and let me make sure we get this right, the interfaces. Let's knock the interfaces out first. So gig 00, we're going to say no shut, and then Ipv6 address FE80::3 link local, and then Ipv6, they've got us doing a global unicast here of 2001:DB8:3:1/64, and I keep forgetting to put address there. All right, and we already did the no shut, so we should be good there. Let's get into interface serial 000, where we're going to say Ipv6 address FE80::3 link local, and then don't forget to no shut it, and then Ipv6 address 2001:DB8:2:2/64. All right, so that should do it on the addressing. All right, so router, oops, sorry, we need Ipv6, router, OSPF 1, right? We need that router ID, and the router ID is going to be 3.3.3.3. So very straightforward, and kind of, when you look at it, it's more of a repetition of combining 8227 and 8335, those two packet tracers which stood by themselves, into this single activity. Okay, and once we've got that, let's get into interface gig 00, Ipv6, OSPF 1, area 0, and then interface serial 000. We go to the up arrow there to save us a little time, and we should see an adjacency forming here any second now between routers 3 and 2, and we have that. So let's do a quick confirmation here. So show IPv6 OSPF neighbors, right? So there we go. No DR/BDR election here because, again, this is a point-to-point interface. And then we're going to say show IPv6 OSPF database, right? So here are my type 1 router LSAs, right? Here are the type 8 link LSAs. Here are the intra-area prefix LSAs, right? Okay, so everything looks good there. And now, whoa, we're going to configure some PCs here, it looks like. So we'll do PCA and B first. So we'll pull PCA up here. We'll go to the desktop and PCA. And what does it say? Okay, so now it's making sense as to why they wanted us to use the last assignable IP address in the IPv4 subnet. So, and that's for PCA and PCB, and PCB and C IPv6 addressing must use the second assignable address in the network and the link local FE80 address as the default gateway. So that'll be easy. Let me read the rest here. Verify configuration. Okay, so we're going to use the last usable address. So let's get the pin out here, and it might be obvious, right, but maybe not. So we're using 172.31.0.1. Now remember, it's a /23. Now this would be really easy if it was not a /23, right? If it was a /24, we would say that's the first usable. The last usable then is .254. Now, the third octet is a 0, and a 23 is basically 2 /24s. So a 23, when we look at 172.31.0.0/24, and then .1.0/24. So these 2 /24s are what make up that /23. And again, remember, the 23 is basically just 2 24s. And so we take a look at the first, we look at the third octet to see what the first network range would be, which is this one here, and then we just tack on another 24. And that answers our question as we would be .1.254/23. Right, and so that's what our IP address is going to be. So let's go ahead and get that configured in here. Whoops, and we want PCA back. So there we go. So the IP address is going to be 172.31.1.254, and then our net mask 254.0. Default gateway is going to be our router gig 00 interface 172.31.0.1, and we don't need any DNS or IPv4 information. So let's go ahead and kick off a quick ping here. Let's see, can I ping 172.31.0.1? So I can ping my default gateway. So let's go ahead and can I say -T here, I wonder? No, it doesn't like that. What about ping -T 172.31.0.1? All right, good. So we can kick off a continuous ping. So here's what I'm going to do. We're going to break out of that, and we are going to ping what is ultimately going to be the IP address for PCB, the IPv4 address, and it wants the last assignable. So same thing there. We start at where are we at? 172.31.2.0, so it would be .3.254. And so we're going to let that run, right, as we scamper over here to PCB, where we've got some IPv4 and Ipv6 configuration work to do. And so we'll leave the topology out of the way here for a second. So let's pull our desktop up. And let's come to the IP configuration. We're going to say static. So my IP address is going to be 172.31.0.1. 172.3.254, my subnet mask, 255.255.254.0, and then my default gateway, which I'm definitely going to need, 172.31.2.1, and this should get us going from an IPv4 perspective here. And you can see the request timed out. We've got some unreachables. We'll give it a second because we'll put in the IPv6 information here. And that is going to be, and what was it looking for there? The gateway is going to be FE80. And it's interesting, it put it in as ::2, but we know that it's FE80 ::1. And then the IPv6 address, it's asking for the second assignable IPv6 address in that range coming off of this. So it should be 2001 :DB8 and I just lost my place, :1 :2/64. Oh, I'm sorry, link local. My apologies. I looked down and then looked up. So FE80 ::1. All right, so let me close this and let's see, can we ping 172.31.1.254? So we're not getting any response from router 1, right? You can see the request is timing out here. And let's see if I can ping my default gateway. So can I ping 172.31.2.1? Sorry, I was going to say .4.1. All right, so I can ping my default gateway. Let's see what happens when I say trace over to 172.31.0.1. Whoops, trace RT. So I make it to my default gateway, and then do I get any further? I do not. So let's troubleshoot this IPv4 issue that we seem to be having here. So here on router B, let me go ahead and say, let's say end. I'm going to say show IP route. And do we have a route, an OSPF learned route? So we've got this /23 here, right, for the 172.31.0.0/23, which is correct. And we do see it, and did I put in 4.1? Let me make sure, was that right? 4.1, 4.2. So we do have that. So let me go ahead and see, can I ping from here? 172.31. And we're doing PCB.1.254. All right, so I've got connectivity from the router. So maybe, did I typo something here? Let's see, 172.31, and that is my default gateway on router B. It should be 2.1. That is correct. So I've got reachability there, so let's see. Let's bring router A back into the fold here. Let's see, do show IP route. Aha! So no learned OSPF route for what I would need to return to, which is that LAN segment behind router B. So let's take a look here and let's see, did I put in or did I forget to put in? And there's the answer, right? Take a look at that. Fortuitous failure here. So router OSPF 1, I need my network statement for the 172.31. And let me make sure I get this LAN segment correct, .2.0, and it's 0.0.1.255, area 0. And something tells me that we should have some success here shortly coming from PCA. And in fact, here I'll kick it off anew, and there we go. All right, so we've got IPv4 connectivity. We had a missed network statement there. So now let's come over to, we need that topology back. And we're going to jump on PCC. Whoops. And we'll go ahead and we'll just roll with this until we actually Need some space back. So PCC, there is no IPv4 information, but IPv6, use the second assignable on that segment. So 2001:db8:3::2, and that's a /64, FE80::2, and then FE80::3, right? So now let's see, do we have connectivity? If I was to ping 2001:db8:2, and I'm double checking, no, :1::2. All right, and we've got connectivity. So let's confirm by checking results. And everything looks good. For whatever reason, they didn't have the score shown there, but here we go. 58 out of 42 out of 42, or 58 out of 58, however you want to look at it. So we are good, right? Again, couple mistakes, but mistakes happen, so I leave them in there, right? And then we can go through and work it out and troubleshoot. So a couple key things to remember. The wildcard mask is going to change because that is not a /24, right? Remember, this is a /23. So we have to make that adjustment. And basically, we've got V6 and V4 running in the same network, at least on router B anyway. And then over here to the left, we were V4 only, and over here we were V6. All right, well, this is going to wrap up the skills integration challenge, right? Not much to this one, very simple, low-hanging fruit here. So that is it for 8.4.1.2 and Chapter 8 in general. All right, I will see you all on Tuesday. Have a great weekend.